Hello friends, this is Partho sir. Very good morning. Today I am going to discuss one important area of definite integral where we will find that how the inverse functions is used in a definite integral problem where the application of box function, that is the greatest integer function, is incorporated. Now, in the recent few years, we have seen in IIT Advanced, JEE Main, as well as BITSAT and many other competitive engineering examinations, there are certain problems coming in a very integrated form. So we have to accumulate the knowledge and idea of inverse function, greatest integer function, along with the definite integral. So let's see how to solve this particular problem. The problem which is given, the value of the constant is that is a greater than 0, such that this condition, that is integration 0 to a tan inverse root x dx is equal to integration of 0 to a cot inverse root s dx, where it is mentioned that is the box function, that is denotes the greatest integer function. So this is within the box, not simple bracket. So this will be within the box function. Okay, so both these two will be within the box, and I hope in the last 3-4 lectures we have already discussed what is box function. Now the given integral, if you just see this given integral can be equal, this can be, both will be equal only if, so this 2 will be equal only if you find that this a, if it is greater than tan square 1. Why it is so? Because first it is mentioned, now see, the value of the constant a greater than 0, so it cannot be negative, it will be greater than 0, meaning it must be a positive. But here if we consider the lowest value, because tan square 1, it cannot be negative. So starting value tan 1, and if we just make it square, then automatically a has to be greater than tan square 1. So here the range of tan inverse of root x is given. So if you put the value of x of tan square 1, so we will get a value of box function of 1, which is integrated from 0 to a. So now we will just write it down in this manner, that is integration of 0 to a box function of tan inverse of root x dx, that will be equal to 0 to 1 tan square 1, that is the box function of tan inverse root x dx, plus integration of tan square 1 to a, that is box function of tan inverse root x dx. So in the first case the value of this will be 0. Why it will be 0? Because if you put over here what I did mention before, that here we will get box of 1, and the box of 1 from 0 to tan square 1, automatically the value will be 0, because it will be a fractional part, fractional number, that means obviously we'll consider 0. Because as we have seen that if we put within the box 0.324, so in that case we take the greatest integer portion, that it will become 0. If we put 0.524 within the box function, we will take the value that is 0. So similar manner, if we take this one, it will be 0. And in the second case, if we put it over here, then the value will be tan square 1 to a 1 dx. Now after integrating these two parts, we will get x, which is upper limit a and the lower limit tan square 1. So it comes down to a minus tan square 1. Okay, so the ultimately value which will come, that is tan square 1. So this portion we will get the value, that is a minus tan square 1, that is the equation number 1. Now if we integrate the second portion, that is this one, which is integration of 0 to a box function of cot inverse root x dx, what you will get? Now see what we can get out of here, that is integration of tan square 1 to a box function of cot inverse root x. This is the part 1. Because why it is so? Because we are integrating 0 to a. So tan square 1 to a, that is the first part, and the second part obviously will be a to 0, that will be 0. So we need not have to write that particular portion. So ultimately we are going to get 1 into cot square 1 minus 0. So overall, if you see that here it is mentioned, this integration of this portion will be equal to integration of this portion. So a, that is this is equation number 2. So what we have got over here, you have got it that this is equation number 1. You have got it, this is equation number 2, and here it is mentioned 0 to a integration box function tan inverse root x dx is equal to 0 to a integration cot inverse root x dx. So these two will be equal. So ultimately we will get a tan square 1 is equal to, that means this one will be equal to this, that means cot square 1 minus 0. Okay, so we are going to get a is equal to tan square 1 plus cot square 1. So we can break it up in the form of sine square 1 by cos square 1 plus cos square 1 by sine square. And now what will happen if we integrate it further? So we will get it, it's simplify it, that means 1 minus cos of 2 by 1 plus cos of 2, and this plus 1 plus cos of 2 by 1 minus cos of 2. Further, if we proceed and if we take the LCM of these two, so we will get 1 plus cos of 2 this whole square plus 1 minus cos of 2 whole square in the numerator, and the denominator will be 1 minus cos square 2. So it comes down to sine square 2, and the upper portion will be 2 into 1 plus of cos square 2. So this ultimately end this problem, that is this is 1 plus cos square 2, that means 2, if you multiply both the numerator and denominator by 2, so it comes down to 2 into sine square 2 by 2 into 2 plus 2 cos square 2. So this ultimately lead to your the equation, that is 2 plus 2 cos square 2. So this comes down to 3 plus cos of 4, and this equation becomes 1 minus cos of 4, and this is the final answer. So this value of these two integral, ultimately if we just compare and if we consider the value of a which is greater than 0, so ultimately we come to know that the value of a which is greater than 0, the exact value which come, that is 2 into 3 plus cos 4 by 1 minus cos 4. Thank you very much.